Whenever we talk about divisibility and integers, it is natural for the conversation to turn about prime numbers. After all, prime numbers are the only numbers which have the property that their divisors are 1 and themselves. So in a way, the prime numbers are like the building blocks of other numbers. Theorem 4.3.4 basically says that every integer greater than 1 is divisible by a prime number. And although I'm not giving you the proof right now, the proof is in the book. And in a later section, I'm going to give you another way to prove this theorem. This is closely tied to the unique factorization theorem, which is also known as the fundamental theorem of algebra. There aren't that many things in math called fundamental, so you should listen up when you hear the word fundamental. The only other one that is called fundamental is the fundamental theorem of calculus. Now, the fundamental theorem of algebra basically says that if you give me any integer n that is greater than 1, then I can turn it into a distinct product of prime numbers with specific positive integers for each one of those prime numbers. So this prime factorization is basically unique, except for maybe the order. Maybe your answer is going to have a different order than mine, but we will both have the same prime numbers with the same positive integer powers. The form above, where the smallest integer is first, is known as the standard factored form. So let's see if we can write the number 18,900 in standard form. How can I do this? What I'm going to do is basically break down the number 18,900 as follows. First of all, I know that it can be divided by 100, so I'm going to split the number up into 189 times 100. 100 itself can be turned into 10 times 10, and 189 can be divided into 6 times 3. And from there, I'm just going to keep dividing every number until I have all the primes listed. Once I have the primes listed, I'm going to reorganize the list from smallest to largest and counting how many primes there are. For instance, 2 is shown up twice, so that's why I'm putting 2 squared. Whereas 3 shows up 3 times, so we put 3 cubed. 5 shows up twice, so we put 5 squared. And finally, 7 only showed up once. In this example, the P1, P2, P3, P4 are the primes in the base. 2 and 3 and 5 and finally 7. And the exponents are the powers of 2, the powers of 3, the powers of 5, and the power of 7.